And I've got a little demo if we have time, so that might be.
Oh, okay.
Wow, excellent. Well, Marcin, how do you want to run the meeting?
So agenda for me is, I mean, I was hoping the idea there was a crash course on the RTK GPS module with the intent, like if we're gonna do the skid steer with that, but ideally think about it as crash course for dummies with intent of mass replication. Because I mean, I think that this kind of technology, if we do it right, I mean, it's going to get wide adoption altogether. So I think this is that's why I'm saying this is historic moments, because RTK GPS, I mean, it's high tech that now is becoming super accessible. So yes. Do you want to does that make sense to basically, okay, crash course with intent, like this is not for theory, this is like, okay, how we're going to build it, first overview, and then how we're going to actually build it.
For sure, not sure.
And what kind of best architecture, like simple architectures, like can we even do this with?
For sure.
Okay.
I was not unaware of your knowledge of GPS. So do you kind of know how GPS works?
A little bit, but this is for dummies, so you're explaining to the world. Because do you mind if I record this for the rest of the world?
Go for it.
Yeah. Yep. Okay. Yep. Great.
So this is a hodgepodge of slides from different presentations that I've done, so I apologize if it's not totally threaded. But primarily how GPS works, we got these satellites way up, it's 12,000 miles above us, and they're all transmitting some sort of signal. All it is they have very accurate clocks on their satellites. And the receiver picks up those signals and can calculate based on the time delay where it's located on the face of the planet. Does some incredible math, has to do with relativistic physics. It's just amazing what humanity has done to get to this point. But you don't have to worry about any of that, because when you get a GPS receiver, it calculates all the stuff, crunches all the numbers, and in the end, what it outputs is serial. Now, Marcin and Avinash, have you guys are familiar with serial communications? You know what characters look like?
You got to go to dummies. Dummies.
Perfect.
This is like curriculum for people who are going to start this and have no clue about this, but we're going to teach them in short time to do all of this.
This is it. So the module outputs these characters in visible ASCII, and it looks complicated at first, but then as you sort of absorb it, it becomes more simple. So every GPS receiver in the world, you power it up, and it just starts spitting out these these characters. And what these are called NEMA sentences, and they start with a $sign and they end with an asterisk. And you can see as sentence after sentence, each one of these has a unique. It tells you different information. The one at the top, GNGLL, is the longitude latitude sentence. And so it has commas in between the different sections of the sentence. It's just CSVs. It's concatenated stuff. And so if you can break these serial sentences at the correct spots, then you can understand where you are in the world. So that is our latitude. That is our longitude. We can see the date. We can see the altitude. Now, there's a bunch of other information here that, some people need, most people don't. All of this is usually represented inside of an application, right? A user looking at this is not really helpful. This is just for machine communication. But just know that every GPS receiver in the world outputs these serial sentences. And if you can parse these sentences, then you can know where you are in the world. Okay.
Receiver? You mean transmitter?
Receiver. GPS is only receiver.
Mm-hmm. Okay.
The satellites up in space are the transmitters, and then the thing that we hold in our hand is the receiver.
Okay. Receivers.
Mm-hmm. This is an example of a receiver, very low cost. I think it's $30 or $40. It's about the size of a quarter, and you don't have to do anything. You turn it on, you power it up, and then you wait approximately 30 seconds, and you'll know where you are anywhere on the surface of the planet with about a couple foot accuracy. 2 meters is pretty normal off the shelf.
Mm-hmm.
Okay, so your cell phone, your cheapo receiver off Amazon, whatever it is, they work great, right? You can tell which side of the street you're on. Generally not very big. You can see that sort of peach color thing. That is the antenna. Now, if you point that down, you're not going to see any satellites that are above you. You have to point the antenna up so that you can get the reception from the satellites. GPS does not work indoors. Now, there's some asterisks to that, but generally speaking, it's an outdoor only clear view of the sky thing. GPS does not work underwater. right? As soon as you get any kind of moisture or water above you, that eliminates a lot of the GPS signals, and you just lose it. So GPS is an outdoor, open sky for the most part thing. Now, to get into the gritty details of some of the things that we offer, we have, Avinash, you have the facet, that's the thing on the left. It's got a red housing, yeah, totally. It's got a bumper, it's got a display, it's $800. It works well. One of the downsides to that particular version is that it is not waterproof. And today it is snowing, sleeting outside, and there are times when you really want that weatherproofing. The one in the middle is really kind of fun. That's called our postcard. It's cheaper. It's very DIY. The first two are open source. The middle, the postcard is very popular with hackers, DIY folks just putting stuff together. And it's about $375 to get that system up and running. The last one is our torch. That's this guy. And it's just, I call it, it's a tank. Right, it's waterproof to a meter. You can drop this in a tank of water, and it'll survive for over an hour underwater. So really good for harsh environments where surveyors are throwing it in the back of their pickup truck and not thinking about it. That fourth one is the breakout board, where that's the nerd's board. If you want to be at a bench and you're building some sort of project, that is the embedded system board. But you can see that it's just as much as the postcard that has the display and the antenna and everything you need to get up and running. So, in my opinion, we're going to talk about your use case, but the postcard is likely where I see open source ecology being, or that breakout board, the embedded system. You guys are not necessarily focused on survey; you're focused on machine control.
But both, though. I mean, both applications. Okay. Eventually, I mean, we build houses. And we'd like to open source the survey process as well. I mean, because that's one of those bottlenecks. I mean, we just got a survey, $2,000. I mean, it's ridiculous. It's like, okay, and I don't want to spend $2,000 on every single house I build. So
that's a sticky subject, because these are devices that will tell you very precise location. Surveying is a whole. It's like a legal thing. Yeah. Right. It has nothing to do with data. It has everything to do with legal stuff. So,
quick question. SparkFun RTK facet, do you have also the open source files for the casing and all that? Somebody can build it completely completely?
Yes. So it's an open source thing. We open let me think about that. The step files are available for the housing, and then we can get access. We have the Fusion 360 files if people want them.
Wow. Has anyone actually built it themselves by buying the components?
No, because there's 3 boards in there. There's some ribbons. There's an antenna element. I would say it's a complex build for folks that are not diehard.
Yep. Okay.
Most of our customers are, they want to lay out a fence line.
Yep.
Right. They want to locate some utilities on their 300-acre forest, whatever. So it's a lot of different use cases.
Yeah, but then again, if somebody takes the facet files and buys the postcard, they can play with it and say, oh, this is my facet.
Yes, absolutely. Okay. They can piece it together and have a very good experience. Let's see. That's. What other questions do you have?
Keep going.
Okay, so when you start with a GPS receiver, it's fine off the shelf. Even the very expensive GPS receivers can only get down to about a meter of accuracy. For them to get better than that, they need a land-based or a terrestrial-based signal for them to correct what's going on in the ionosphere. Because the satellites are so far away, there's a lot of humidity. It's not clouds, it's just turbulence in the ionosphere that delays those signals. So even though the receiver is able to triangulate its position, it's always going to have a bubble of error because the signals are little noisy. So what we do, what the industry has figured out, is what's called a base rover system. You're the rover. You're the guy with the stick. The base is some sort of solid structure, a barn, a building, a whatever. It could be a tripod, but there's a device that's another GPS receiver that's sitting there, and it is not moving. And it is told, hey, you're the base, and here is your position. We can find its position a number of ways, but if we know its really accurate position down to a couple millimeters, well, whenever it sees a signal, that base station gets a signal and says, hey, base station, you're actually located 6 inches to the left. Well, the base station says, that's impossible. I'm bolted to the ground. There's no way I can be 6 inches to the left. Aha, there must be a delay in the signal that I got from that GPS. Yeah.
With a base station, can you get the cheapo receivers for $30 and actually do this kind of accuracy?
No. You got to have an expensive one. Yeah.
Okay.
But we'll get into where we can get access to base stations.
But is that a question of computing power, or?
It's a more expensive receiver. You have to have a more expensive receiver as a base station that can generate corrections every second.
More expensive receiver. So it's just those receivers. No matter how much compute you put on top of that, you cannot solve yourself out with computation using a cheap receiver.
That is the current state of things. Yes, you need a good enough RF front end to be able to receive multiple frequencies.
Okay.
We can get into this. It's L1, L2, and L5. The really cheap ones only receive L1, where to do these corrections, you need to get at least L1, L2. So the more expensive receivers have a better RF front end that's capable of receiving additional signals from the GPS network.
Yep. And just a question on the postcard architecture. I mean, you've got the chip in there that you source from somebody else, and that chip that's not open. I mean, none of this kind of stuff is open, but your design of the actual integrated circuit is.
Correct. We are systems integrators. So the module comes from a vendor such as uBlux or Quectel, and then we surround that with battery chargers, displays, switches, firmware, Bluetooth, all the jazz that you need to make it really tick. Mm-hmm. And all of our work is open source. We don't have control over the chips, so we can't open source that. But it's KiCad all the way down. So we have KiCad files, the firmware is open source, all that jazz. Okay, so we've got a base station. It knows where it is. It knows that if it gets an erroneous signal, it can then calculate a correction and say, aha, that signal is delayed by X amount. And so the base sits there, and every second it spits out corrections, right? And it's this, it's like 1K of data. It's not a lot. Now, as a rover, I'm moving around, and I've got my 1 meter or 2 meter inaccuracy bubble. So I kind of know where I am, but not very accurately. Well, as soon as I can get those corrections from the base station, now I can correct all those signals that I'm receiving and say, no, I don't know where I am within a meter. I know where I am within 10 millimeters, 2 orders of magnitude better. That's the width of your pinky nail, right? So now XYZ, now I've got my hamburger or I've got my little antenna, and I know exactly where it is, and I can do all sorts of fun stuff. But
in all 3 dimensions, including Z?
Yes, XYZ. Z is the worst. Z is about double of the horizontal. So if you've got 10 millimeter in horizontal, you're going to have 20 millimeter in vertical.
Okay.
Now this thing's moving. It needs to get those corrections approximately every second. If it misses 1 or 2 seconds, that's fine. If you miss 15 or 30 seconds, then you're going to expand your correction or your error bubble back out to that 1 meter. Okay. Mm-hmm. So that's how RTK works. You got to get corrections. You got to get them from somewhere. Now, I looked before this presentation. Missouri has a free statewide system. Okay, so you don't need to set up your own base station. You can tap into the Missouri Department of Transportation. Lots of states do this. Colorado sucks, but Missouri, Florida, Wisconsin, Massachusetts, they all run these states because it's a general good. It's good for surveyors. It's good for the Department of Transportation. It's good for everybody to be on the same base station network, so that when we go put a stoplight in this location, everybody agrees it's this location. We're all using the same base stations. We're all using the same corrections, so we can get the really nice RTK. Nice. I think it's 13 or 14 states have free systems. Missouri is one of them.
Nice.
If you don't have a statewide system, you see all these kind of green dots. That's UNAVCO. That's another governmental organization. They're focused on earthquakes and plate tectonics and all sorts of stuff. So they're very heavy on the West Coast and in the islands. The rest of the country, not so much. Now, if you want to get into pay to play, it's $15 a month from companies like Point Perfect. They've got good coverage over the US, EU, and parts of Australia and Asia. The problem with base stations, if I go back one, you can see The further you are from a base station, you add inaccuracy. So for every 10 kilometers, you add 10 millimeters is the rule of thumb. If you're hundreds of miles from a base station, that's too much discrepancy between the ionosphere of where you are and where the base station is for those things to apply. So you got to be physically near a base station. That means that there's going to be holes in your map. Missouri, you're probably covered, but in Colorado, if you look at that map, what have I got? I've got a couple green dots. If I'm like, 50 miles away from one of those green dots, I don't have coverage. So there are companies that sell service where they just carpet bomb an area. And so if you need total coverage, if you don't know where you're going to be, you can pay $15 a month and get corrections.
But you're saying of the free Missouri service, we could be up to like 30 centimeters if it's like on the other side of the state.
Correct. Yeah. I believe worst case, you're going to see 30 millimeters.
You said 10 millimeters per 10 kilometers?
Correct. How they're running multiple base stations. They're going to have an array of base stations across the state. It should be, worst cases, you're directly in between two base stations. I don't know what those distances are. I haven't looked at the.
So you're implying like 50, maybe every 50 kilometers or so, there's a base station or such.
Correct.
Okay.
Correct. They're going to run a couple dozen across the state so that they have as few gaps as possible.
Okay.
Okay. So let's see, there's that. Now I want to get into sort of the nuts and bolts a little bit. So hopefully this will paint a picture of how you're going to equip your skid steer. Generally speaking, it's over Bluetooth to a cell phone. Okay, so I've got my cell phone, I've got my facet that Avinash has, or I've got my torch. I'm going to turn the thing on, I'm going to start using my cell phone, and then they connect over Bluetooth. Generally speaking, Avinash, I'm really sorry. iOS is terrible. If you can avoid Apple phones, Bluetooth is very difficult on iOS. We recommend Android because it's just so simple. And what this list of ArcGIS field maps, Quick Capture, Diamond Maps, Field Genius, all these things are GIS apps. They're free apps or sometimes paid that you run on your phone, and it allows you to capture points and calculate areas and do all sorts of surveying sorts of tricks.
Oh, nice.
Okay. SW Maps is the one that we really love. It's free, developed by a gentleman in Nepal so that he can map out various support infrastructure for some of the.
And which of these software are open source?
It's a great question.
So I'm assuming SW Maps is open source or no?
It is not. Vespucci might be, QField might be. Yes, I know there are some out there. I'm not familiar with their open source status.
And do you have any concerns regarding using SW Maps for security or anything regarding open source?
No.
Not really. Okay.
Not really. So yeah, SW Maps, there's not really a transmission of information. It's just, pins, you're recording pins and pin locations. Seems pretty local. So over Bluetooth, I am pulling those NEMA sentences back down to the phone. The phone is representing them on a map and allowing me to do worky things. Park open source GIS. Oh, there you go.
Yes.
Bluetooth is coming across that link. Now, again, if the receiver's turned on, it'll have that 1 meter bubble. So we have 1 meter inaccuracy coming across to our tablet, our cell phone, whatever Bluetooth sort of thing we got in front of us. Now, the next step is corrections. So my phone has to connect out to the internet, and through the internet gets, you're going to connect to the Missouri Department of Transportation's website, and then you're going to pull down 1K per second in the background. That is then going to get transmitted over to the RTK device. That RTK device is going to go, oh, corrections, I love corrections. And then it's going to get its RTK fix and have really, really accurate location. And that's what we do. And so your Bluetooth just sort of hands stuff back and forth. The cell phone constantly, every second, is pulling down a little tiny bit of data, and life is good.
So is our skid steer going to be working with a cell phone? No, we're going to put this on another device, right? Or no?
Is that a question for us?
This will be a good time, I think, for me to jump in. Let me drop also this link in here.
Okay.
Make sure everything is running properly on my side.
Can you speak clearly? I'm having a little bit of trouble hearing you.
Yeah.
Okay, there you go.
Maybe this is a share my screen time, or maybe it's join the link in the chat time.
Yeah.
Hey.
let me just do both. Let me share my
Yeah.
screen as well.
What is
So
this, Avinash? This is
What you're
awesome.
seeing is a real-time stream of the GPS behind me. So let's see, share my screen.
Oh, nice.
Yeah.
All right, great. So to kind of prove that I'm being honest, if you look at the longitude, the kind of last 3 digits of the longitude column, and then I'm going to move it, and you see it spike up to like 700. So, and to the points that were being made, I'm not 100% sure how accurate that is because I'm in a closed space,
Yeah.
Which is also under another closed space, but I'll talk about that.
Okay.
But basically, I'm streaming this on a Python web script, and that's uploading to a web app that I developed, and it's all being hosted on AWS server, web server.
Yeah.
And my goal here is I've been working on it a little bit, and Marcin and I will synchronize separately.
Yeah.
This will connect with a visual odometry stack for a drone. So essentially, we're collecting our real-time GPS data from Facet, streamed to a web app, simultaneously connected to that web network will be things like a drone or even things like a cell phone camera, where an operator can just go around and do a quick map of the boundary of the area, and then synchronize those two streams of data to create a workflow for basically a path map for the skid steer.
Nice.
So this software could in theory replace SW or any other software, and I just haven't uploaded it to GitHub yet, but it will be in the next few days.
Okay, and this would be, so our plan, Avinash, is that, I mean, we're talking about some kind of a thing like a Raspberry Pi, or what device are we going to use for compute?
This is just happening on my Windows machine, which is simply running one Python script, which is just collect Bluetooth data, convert it into web data, and connect to the web server and stream that data.
Okay.
That could happen on an Arduino, really, on some level, but it could happen on a Raspberry Pi machine.
Raspberry Pi. Yeah. That to me is the concern. We like to say at SparkFun, data is easy, information is hard. So we are providing you with longitude, latitude of that facet, and cool, it's right there. What do we do with that? And so eventually you need to translate that, I think, into motor control or directions to an operator, and that's the really tricky part.
Okay.
I'm looping this into a project for Park Precision Agronomy Research Center called the Ground Control Project. So this idea that, it's part of a larger topic, but I'm actually sitting in, I'll do is stop my share real quick. I'm sitting in a mobile laboratory. So this is part of the other half of my time is I do STEM outreach in a mobile lab.
Wow.
And it's a small space, but it's extremely dense. Got 3D printers and VR headsets. It's got an immersive forklift simulator. And we take this mobile lab to
forklift simulator?
Yeah, it's got an immersive forklift simulator that actually could, in theory, be connected to something like an autonomous skid steer.
Wait, did you do that, or that's off the shelf?
Some of this stuff is off the shelf. Some of this stuff is not. For example,
Avinash, you froze, buddy. Wi-Fi.
The script for that. Some of this stuff I could, in theory, build a haptic steering wheel, but I just don't want to do that. Anyway, long story short is, one of the things that Park does is finds places to put our mobile labs, and we need to do some rough surveying to get an idea of where to park these, like pads that are level enough to put these on. And so that's something that Park is working on with the Facet module.
Wow.
Super cool.
This is good.
Super cool. Yeah. So, Marcin, do you envision, a display where a user is told what to do? Like, hey, you're 6 inches too far to the left, you need to turn to the right. Or do you envision that the skid steer will drive itself?
Both.
Okay.
So we want to set up for both, but it's a question of rollout. So what's first is the question. I mean, indeed, like the simple low-hanging fruit stuff is, which you don't need RTK GPS, but just remote control. I mean, but I don't know how that even plays in here. Things like remote control just for safety, like So I get in and out of the skid steer all the time under lifted arms. So that's dangerous. Some people die every year from that. So things like that. Start with remote control and then go into things like automated materials handling. Like we've got our workshop, we're bringing materials over to work on like lumber piles or whatever. So thinking about whole facility automation. But before that, the way we started this initially is let's solve for automated foundation grading.
Yes. Okay. Okay. That's, these devices will output latitude, longitude, altitude, and then there has to be some additional app or layer of code that translates, the what you call ground control. The ground control. Hey, we need to level this thing. How are we going to do it? And that's complicated. And I'm only the data.
That's fine, but man, so I would be scared about this discussion even a week or two ago. But man, AI is transforming this world here because so Nathan and you guys. So right now, I'm not doing stuff in FreeCAD anymore. I'm just using AI to program FreeCAD for me parametrically. Can you believe that?
Yeah.
So I'm designing house modules. I'm not just give me a wall module such and such with these studs. It blows me away now. I mean, I can do that. I'm not a programmer, and I'm able to do that. So when you talk about this right now, I'm like, oh, okay, cool. Chat GPT. Let's look at some of the avenues to implement this.
Awesome. I think that's a worthy approach. And I agree with you. It's less daunting the more months go by.
Yeah, man, it's things are changing.
Cool. Let's see. So I have one slide left, which was, I just want to be sure that we cover gotchas.
Yeah, so, yeah, cool. But right after this, maybe if you can actually take a look at, okay, here's the board. Here's how you connect everything to it. Maybe you could go over that real quick after this.
Sure.
Okay.
We'll talk low-level hardware in a second. So just know that the first gotcha is antenna placement. So, on your skid steer, you're going to have what's a UFO or some sort of antenna on the top of the skid steer. Now, that will tell you with extreme accuracy the antenna receiving element. That you have to do some sort of translation to get down to the bottom lip of the skid steer bucket.
Yeah.
Right?
Yeah.
All we're reporting is where the antenna element is. It's so accurate that you now need to do a translation to do actual work. Cellular coverage. So if you're out in the woods of Missouri, do you have Wi-Fi or cellular coverage? If you don't, that's fine. We did a video on Starlink in a backpack. So for $5 a month, you can get their minimum standby service. That minimum standby service has enough bandwidth in it to support end-trip corrections.
Okay, nice.
Okay. $5 a month, it's wild. You turn it on, and anywhere in the freaking world, you can have. Now, you can't stream videos, you can't, do crazy stuff. But if you're just doing corrections, that's 1K per second, which is way under their kind of free $5 threshold.
This is anywhere in the world, including Mexico, for example, Mexico, or collaborating in Mexico.
Yeah, absolutely. The only place where it gets a bit dicey are places like Ukraine.
Okay, yeah.
Right. Starlink is actively doing some things that I don't fully aware of. But no, Starlink is, for as much as I dislike the people and the politics behind it, it's phenomenal technological advance. So if you need internet in the woods, we're recommending Starlink. Okay. Lastly, tree canopy. So Avinash, you may have experienced this, like when you go out to your property. The canopy, there's surveyors that will only do work in the winter because that's when the leaves drop and you can get better reception on your GPS receiver. So it will work sometimes. It's just if you've got dense canopy. I mean, I'm out here in Colorado and it's wide open, right? There's trees here, but I don't understand foliage and canopy like other folks do. And so, just know that a dense canopy can cause issues for RTK fix.
Okay, but that depends on where your base station is. So if you clear that path, then you're good, right?
No, it depends on your immediate locale. So if you're looking up and you've got a whole bunch of trees and branches and really dense foliage, that's going to block the signals to my rover. And now my rover isn't going to have enough quality reception to have the really high precision fix.
Okay, but what about the correction station?
The correction station generally is in a very controlled environment. So it's going to be on the top of the building. Missouri Department of Transportation, their base stations are going to be great. If we're setting up our own base station, we really do recommend that base station users find a nice place, clear view of the sky for their antenna. You want the base to be.
Just to summarize it, so you're saying that it doesn't matter where the base station is, it matters if you can see the satellite.
If you can see the sky. Yeah.
Okay.
We've heard reports where folks will, they'll stand in an open area, get an RTK fix, and then they'll walk into wherever they need to take a point. And if they do it within the next 10 or 15 seconds, it is very accurate. But after that 10 or 15 seconds, you could begin to introduce so much error that it's not of high enough value for them to do it. Now, a skid steer may not care about whether they're getting 3 centimeters or 6 centimeter accuracy. I don't know, but depends on the use case.
So, but like, say you got a full canopy forest. I mean, so that means your resolution is just going to be really bad, or it's just not going to work, or
difficult for me to say. You will have issues. Right? You will perhaps get an RTK fix. That RTK fix may come and go. And so that can be really annoying to a machine user because, they can do work and then suddenly they lose their RTK fix and they don't really know where they are. Can they continue work? No. They have to somehow resolve that.
Okay. Cool.
Okay, so now you wanted to talk. I'm going to stop sharing here, and let's switch to kind of hardware and how we would hook up hardware.
Maybe you can tell us about this is the minimal way to make this work. Maybe even with an Arduino versus this is what you really want. Can you talk to us about that? Like
please.
In a style of minimalist Arduino where it's just the chip and a couple of wires and components. What would that look like for this system?
Absolutely, and I'm not here to sell stuff. I'm going to try to answer your question as simply as possible. This is the postcard. It has an optional sort of display and battery charging and all that jazz. This is a very nice RTK receiver connected to an ESP32. So the ESP32 gets you your Bluetooth. That's the thing on the left. The thing on the right is the receiver. You've got an SMA connector. That's the gold thing up top. That's where you screw on your antenna. So for your setup, this, I think, and Avinash, I would love for you to chime in as well, but this sort of setup is pretty robust. You have USB-C for your serial, so that would plug onto a Raspberry Pi. If you want to get really hardcore, that white connector, kind of beige connector next to the USB-C connector is where you get your raw serial. So, you could even go more low-level embedded if you wish. But for, I think, this application, Raspberry Pi, USB-C, serial, you're good to go. Now, that gold SMA connector up top, that's where you're going to have a, say, 3-meter coaxial cable that goes up to the antenna that's usually magnetically mounted to the top of your skid steer. Magnetic mount is easy, it's temporary, but that's also the con. On some of these things, you want a really good permanent mount. So I forget the 5/8 inch, 11 threads per inch, 11 TPI is the thread that all the surveyors use. So you're just gonna put all thread on the top of your skid steer. You're gonna screw on your antenna, and then you're gonna run your coax cable down to this board. Is how I would approach it.
Okay.
Don't mess with batteries. Don't mess with charging. You don't need any of that because your Raspberry Pi will provide the power over the USB-C port.
Okay. So if we take this right now, take an Arduino that controls solenoids on the skid steer, is there a way to make this work right now with an Arduino? And solenoid controllers from that Arduino? Avinash, do you see a way? This is I always ask the question. Go ahead.
I might have a little bit more. So my PhD was in the area of robotics design and control of dynamics control systems. And so, yeah, my immediate thinking is we need really high voltage and high current capacity like drivers. And I can help you to source those. But otherwise, for the logic level, my suggestion would be BeagleBoard or Raspberry Pi or Arduino would also be fine under certain circumstances.
And Arduino, like what circumstances would Arduino be fine under?
Yeah, I would just pick like a logic board on there that is sufficiently powered for the computation that we want to do. My more recent experience has been to shift all my heavy computation to web servers and then ping the web server. I mean, this is how, as you said, like AI means GPUs are expensive. Amazon buys all the GPUs, so I just rent compute space from Amazon now instead of running my own GPU or whatever it is. Um, so yeah, I mean, in that case, like an Arduino with a Wi-Fi antenna can offload all the computation to a web server, to maybe the ground control web server, or a sufficiently powerful, Raspberry Pi stack could do the computation we're talking about on board as well.
How robust is the getting the compute off the internet? Is that super reliable?
So the internet side is super reliable. The connection, so to our discussion of how good is your connection to the internet. Now, on some level, that can be throttled pretty appropriately. And then we talked about sensor fusion, so having an IMU stack or the visual odometry from a drone, that could solve some ambiguities. But it depends on your location. For where I am, I'm in a favorable location, which is rural, but still has good internet coverage. So I'm able to do a lot of like high quality web app work where I am.
Okay. Yeah.
Again, I'm not here to sell Starlink, but for what is it, $200, you get a terminal. You put that at the work site, and that gives you Wi-Fi for the whole work site.
What's $200 a month, or is that to buy it, just the hardware?
Hardware, again, these numbers are changing quickly. Last I checked, it was $200 or $250 upfront capital investment for the terminal hardware purchase, and then it was an additional, $130, $120 a month for internet service.
And that $5 plan, that's not going to cut it for this purpose.
So Avinash sort of pointed out, it depends on how much data you're passing back and forth. You might be able to squeeze it into the $5 service. That's really for emergency text messages. And if you painfully wanted to try to log into Gmail and send an email, you can do it. You're just going to have to wait. So depending on how much data you're passing back and forth, in my mind, you pay the $130 a month, you get a really nice pipe to the internet, and you do your work. Mm-hmm. Now, if you want to do it cheap, I bet there's ways we can do it cheaper.
And then if you have a good cell phone with reception, you can use a hotspot from it.
The hotspot depends on where you are.
Okay. Mm-hmm. Yep. Okay.
It's another layer to that that's not trivial. If you're using the internet computation, which I suggest, AWS would, or whatever server you use, most likely would charge you for your data rates. But Park is looking to subsidize that Park is trying to be a cyber physical research center. So we're looking to subsidize that cost. So for example, for open source ecology, we would cover the cost of your web server.
Yeah. What's your funding model? Are you getting grants, or how are you doing this?
We're applying for grants, but right now my wife is just not upset with me today, and that's the funding model. Open up the wallet and make it work. But I think there are a couple of funding streams, but for this experimental scenario, it's good for us to get real use data, so I'm funding it out of pocket. Yeah.
Nathan, what amazing other wisdom do you have to share with us here, Avinash? Because I want to be mindful of your time. I know you run a successful hardware enterprise, open source hardware enterprise, one of the few remaining ones in the world.
Yeah. Thank you. I can't, Avinash, what are we missing? I mean, it's not finicky, but it's sophisticated. And so that's one of the pieces of things we've learned on the forum, where this gentleman was trying to lay out his own blacktop asphalt road, trying to make it straight. And just, if you've got heavy equipment operators, they may not have the knowledge, the patience, or the training to handle, to debug a Bluetooth connection. Right? It can be very challenging just to make what we would consider basics, but just the rest of the world is not as technically savvy as we are. So just know that this RTK stuff requires training and requires sort of, getting people up to speed, because if it's not working, it's not always apparent that your location is inaccurate. They need to be very aware.
Are there commercial systems that, have this down, or is this always a pretty challenging thing for precision operations?
I would say it's required for precision operations, and the folks that have really refined it and honed it charge tens of thousands of dollars for those systems.
Are you aware of people who are using whatever bulldozers or other that are
True.
just doing all?
Yeah, Oh yeah. So the big construction equipment, Caterpillar and John Deere to a certain extent, they run a company called Trimble. And
Mhm.
so anytime you see an Earth mover with the two UFOs, this is a UFO in the
Yep.
corners. That's controlling every and yeah, it's $30,000 to get started.
And they have like a subscription model per month, like that they give you that
Yes.
service for.
Yes,
So
and that's hundreds
say,
of dollars. John Deere locks farmers into this service model.
so it's like 30K capital and then service fee, something like that, or
Correct. And it's usually just all rolled into the cost of the combine or the tractor or the whatever. Whenever you buy a new one, it's got all this whiz bang. And then, oh, by the way, when you sign this, you're going to be forking over X amount per year or per month to run it. So open ag is a really big deal for us.
yeah, yeah. Are you working with individuals, with farmers, open ag people that are working on this? Can you connect us, or I mean, is there some potential collaboration there?
I would encourage you to check out Open Ag. Farmers are some of the most innovative hackers I know, and they will, no one's going to tell them how to do stuff. And so they figure out all the mechatronics to get their tractor to, run a straight line for plow season.
So, are you talking about open ag AI, this thing?
I do not know. Let's go have a
Let's.
look.
I want to see what is this open ag? I'm not
Um,
sure. You know them or?
I do not know OpenAg AI. I have been on the Open Agriculture website a couple times. Their forum. So their forum is extremely active with just folks helping each other. I'm not familiar enough with the Open Ag site to say just that farmers and folks replacing their walled garden equipment is a burgeoning, growing market for us.
Oh, okay. So I see Open Agriculture Initiative, Open Ag at media.mit.edu. Is that maybe the one?
It may be the one. They're rolling their own boards. There's just it's a huge forum of a variety of people doing different stuff.
Do you know any individuals there, or you just know the organization?
I just know the forum.
Okay, so you're not working actively with any individuals who you're helping actually deploy these
Oh
systems?
no. We get pings multiple times per week. Hey, I'm running a whatever TMR 1000. I need to replace that. Do you have any options for service? And so I've got to go look at that specific tractor equipment to see if we can augment or help them with that system.
Do you have, like, say for the your modules themselves? I mean, do you have specific tech support for the RTK stuff, or no? This is just it would be your general tech support for the company.
The Spark Fun is quickly the RTK stuff falls under an umbrella called PNT, Position, Navigation, and Timing. PNT is the umbrella that encapsulates all this precision and timing stuff. So Spark Fun is doing great. We'll keep doing breakout boards, but the enclosed things, this is a very different customer, right?
Yeah.
This is not a hacker. So we have another company called Spark PNT that is doing service and tech support and everything for these type of products. That answers your question.
Okay. Yeah.
I think you're going to be more on the Spark Fun side with the breakout boards and the more of a hacker mentality. These folks are looking to just get work done, and they don't care what's inside.
Yeah.
Okay, I was going to talk briefly about antennas. There's a bunch of different ones, but generally speaking, the $100 ones, the $170 ones, this one in particular, you're just going to need to mount one to the top of your skid steer somewhere. And then you're going to have to do all the math, like I said, to get down to that front edge of wherever you want to do your work.
And this is a product that you make, or this is you just reselling?
We just resell. Yeah, it's got some sophisticated antenna elements on the inside that require more equipment than what we've got.
How much fab do you have actually at SparkFun? I mean, you're putting all the circuits together, right?
Yep. So we have two SMD lines. So we've got two big pick and place machines, stencil machines, reflow oven, automated optical inspection. Next time you're in Colorado, let me know. I'll show you around.
Oh, cool.
Yeah. Come to a tour. We'll show you how the sausage is made.
Yeah.
This one. So if I'm not the best at it, I find somebody who is, and I resell their stuff. So we're not the best at creating antennas. It's a bit of a black art, and so we resell other people's stuff. But something like the postcard, if I go back a page, this is something that we're going to build here at SparkFun. We're going to combine all the pieces, solder them to a board, test it.
And if I were to set up fab at OSC to do this, an SMD line, what is the cost of an SMD line that if we were to actually build it and sell it, and sell things?
It's funny, I was telling the story this morning. I started SparkFun by using tweezers and a hot plate.
Yep.
So you need $50 worth of equipment, right?
But
you get
automated pick and place. I mean, you've got all of that.
You with tweezers. Right,
Yep.
You're placing those components because you don't need a machine to place these components. The surface tension of the liquid metal will put them in place.
Okay.
So a $40 hot plate from Target will heat the board up sufficiently so it'll melt the solder paste and everything will solder. You can do it for under $100. The reason why SparkFun has those machines is because we just have so much volume that you can't have humans do that fast enough.
Mm-hmm. Yeah.
So the machines, you don't need machines to make electronics. You need machines to make a lot of electronics.
Yeah, exactly. But say say we want to make 100 of them, would we, or like at what level would you want to get machines to start automating this?
Avinash, you might know this better than I, but there's a company called, I think it's Oculo, that has an open source pick and place machine. They are really cool people. So I gotta say it's like $2,000, maybe $3,000. I haven't checked on them recently, but that is a truly open source pick and place machine, desktop size.
Oh, wow.
I personally used one, but that's sort of the bleeding edge. That's the state of the art.
And that's for real open source, is not no fake stuff.
His name is escaping me at the moment, but we've had some meetings. He's amazing, really smart guy, dedicated, and yes, very open for real open source. Now, those desktop pick and place machines are fine; they're good. Our machines are somewhere on the order of $400,000, and that's when you get into some like we're toys compared to the Foxcons of the world. So the machines that run in bigger facilities, they get up there in complexity and cost. For us, the $400,000 machines are a sweet spot for, we're not building cell phones. And so they work for us.
Uh-huh. Your setup is like in the 400K range?
A full SMD line on the cheap, I would guess, 450. Maybe 500,000. That would get you SparkFun level quality inspected built devices. Yeah.
Yeah. Awesome. Do you have an open source tool chain for visual inspection?
The automated optical inspection is not
AI stuff. I mean, computer vision type of stuff. You do that, right?
So we do automated optical inspection, and it is very industrial. It's just a machine. It's very impressive what it can do, but these companies that build these machines are not nearly as fast as you are. So there's talk of using AI, but it's not used on a production floor, to my knowledge, yet.
Because we're talking about right here, we're looking at. So I was looking into computer vision integrated with FreeCAD. So you simply take a picture, correct it against a FreeCAD file, and this is the power where AI can take. I could do that right now. I was looking into that.
We attempted this 4 or 5 years ago, and it was fine, but it was not production ready. So if you're doing 100 boards, absolutely. But if you're asking for it to do 10,000 boards day in and day out, you need the repeatability and production. There can't be any rough edges there. If I'm going to introduce that to my production line. So I'm not saying you shouldn't, you absolutely should. It's just not really there yet for our production requirements.
How much bandwidth do you give to these kinds of discussion? Like, are you always talking about, okay, what's the next open source tool chain I can implement, or no, that shark is too far away from the boat?
That's an interesting analogy. I've never heard that one. Generally speaking, we will buy the tool we need regardless of its open source state. So to give you an example, we need to solder headers to boards, so through hole components. The state of the art is this cool laser system that shoots very high power lasers to melt the solder exactly where it needs to be. That's a totally closed system, but that is the tool that we need. And so that's the machine we're going to go buy.
And do you have any bandwidth for actually, do you do any work on open sourcing those tool chains, or no, this is, once again, not close enough to the boat?
It depends on where you are in the thing. I think, forgive me if I get this wrong, but like you're asking, how much time do we have to spend on building our own machines to do this stuff? And that's just outside our wheelhouse.
Mm-hmm.
We're not mechatronic folks.
Okay. And what if there was because I'm thinking like the way OSE is going, like what I'm seeing here is that, wow, if we can actually have dedicated efforts that are crowdsourced for high level open source industrial equipment, I mean, that is worthwhile investments, right? I mean, for example, like if you had $1 million, would you invest that? Well, I mean, I would say it would probably take $1 million to do any kind of development, but say if you had, that's just not on your wheelhouse, because that's, you know, you're away from your core mission. But what if there was a mechanism for doing that? You guys haven't really thought about that level of industrial open source at this time, like dedicated companies like OSE or Park that are doing this kind of stuff, because I think that's the kind of space that the open source hardware movement can emerge to.
I agree, and I'll tell you sort
Apply
of
for a grant. Let's do it.
What's that?
Okay.
Apply for a grant and do it.
Okay.
Let's
Just do it. Let's just do it.
You know, that is the correct approach. If SparkFun had $50,000 to $100,000 in a grant, that means I could hire a person, buy some parts, throw a year at it. That's interesting to me. But as a business owner, I really have to stay focused on other things. Now, let me tell the tale. When we sold our first breakout board for our RTK, it was $300. Have a nice day. When I paired it with Bluetooth over COVID, and I was like, oh, this is kind of interesting. I'll put it in this enclosure as well, just because, you know, you need a nice housing, and I put a sticker on it. I put it on the website, and it was like $600-700. And immediately, it was one of the most expensive things we ever had on the storefront. Immediately, people called me a fraud. And I was like, whoa, what's going on here, folks? They're like, well, what you just are trying to sell me for $700, you claim will outdo my $18,000 terminal. There's no way that you're $700. So what it was an industry ripe for disruption. And so this whole RTK thing over the last 10 years has just been coming down in price by orders of magnitude. What was $100,000 5 years ago is now $18,000, and now I'm doing the same thing for, you know, $300. And there are some really people with me. So to turn that around, like what we had to find was a market that needed enough volume. DIY surveying, machine control, all of that means that I can sell enough units to make it work. When you start talking about an open source pick and place machine or an open source, how many people in the world need one of those?
Yeah,
sure. You know, that's a hard model.
Well, yeah, but that means all the electronic manufacturers in the world would appreciate that, right? So there would be a market.
Thousands of customers, where the surveying market is, you know, millions, tens of millions of surveyors across the world. So it's just tricky.
Absolutely. The 2K open source, I saw it. It's a CC by SA license. It's good. That thing, the $2,000 pick and place. What level of kind of SparkFun product can that do compared to your $400,000 machine system?
Most, it's nipping at our heels. There's two things. There's precision, and then there's throughput. And so their machine has the same precision as our machine, right? But my machine has 8 heads, so it can pick up 8 components at the same time. And that head is moving at astronomical speeds to slam those components down in a very sophisticated traveling salesman algorithm to get that board populated as fast as possible. Their machine has a single head, moves pretty quick, but it's not moving as fast as ours. So, you know, they just cannot have the same throughput, the same capacity as our more expensive machine. Now, I'm sure they're working on it. Multi-head machines are possible. It's just, it's about throughput.
Okay, and the throughput on the open source one, what is it? Can you make like 100 boards in a week?
Yeah. They will have that spec on their website. It's placements per hour, PPH, component placements per hour, something like that.
PPH, and what is your PPH on your big gun?
Marcin, you're killing me. I have no idea. I'd have to go look. It's, you know, 15,000, 20,000 placements per hour.
Data, because I want to turn it into information.
Yeah, fair. Yes, just don't quote me on it.
Okay. All right.
And yeah, Oculo. Go ahead.
I'm just curious, just on SparkFun itself. So you're still, do you say what fraction of time are you working in the business or on the business these days?
See, that is a great question. 8 years ago, I fired myself as CEO, and
Yeah.
now I'm just the guy that sits in the corner and does weird stuff. And so Glenn, the CEI, we get along fabulously. And once a week we get together and I grab my thing. I'm like, Glenn, look at this thing I built. It's amazing. And he's like, that's good, Nate. How's it selling? I'm like, it's selling really well. And he's like, great, awesome. Thank you. Good meeting. Go back to your corner. And I go back to my corner and I just come up with more stuff. So it's going really well.
Okay, so you're not like you're not doing the exact CEI. What is that?
Sorry, CEO, Chief Executive Officer.
Okay. I thought you said I. Okay.
He runs everything. He deals. There's a lot. Just yesterday there was this flare up on the internet about some random stuff, and it's just like, wow, great, Glenn, you got it, cool. I'm gonna go back to my antenna testing that I was doing for this embedded system thing.
Okay. Cool. What kind of products are you? So are you working largely in this precision guidance field right now, like in terms of the product?
PNT. Yeah, the one that we're coming. We got a few coming, but Marcin, it gets so weird. Quantum computing is based on really, really accurate clocks.
Uh-huh.
And so we've got what's called a disciplined oscillator coming out. We already have one out there. It's a thing that sits on your lab bench that gives you a super accurate 10 megahertz clock. Okay, if it's accurate enough, then you and I on different parts of the world can run the same thing on our bench, and we can run experiments and coordinate them with like nanosecond, picosecond accuracy.
Holy cow.
Right. And so those types of clocks were confined to places like NIST and governmental organizations, size of a room. Well, those clocks are now coming down. So we've got this weird clock coming out in a couple months that is accurate up to cesium clocks. So it's atomic clocks, but not the really fancy ones.
Holy cow. So, you're definitely innovating. So this is cutting edge, like in terms of making it accessible, because you're just, engineering down the costs and stuff. Making access.
Correct.
Yeah,
correct. We're taking the fridge and we're decreasing it down to the size of a box, and then we're selling it at a tenth the price and trying to figure out how to make all that work. So it's glorified systems integrators, but we do bring some new look to the industries.
Yeah. So is SparkFun doing well these days? How are you doing as a company?
SparkFun's doing good. So last 2025, we had about a 5 or 8% growth. So we were really timid at the start. Thankfully, when tariffs hit, we raised our prices across the board because tariffs are just another word for customer tax. And so when the parts come in and we get charged astronomical, I think we had an extra $500,000 in tariffs last year. And so that's, we can't absorb that. That would put us out of business. So it raised our prices, levelized it. We're in a pretty good place right now. And so SparkFun was able to grow last year, even amid all of the tariff sort of craziness.
Do you disclose your annual revenue? Like, is there a graph of that from the history?
We haven't closed the books yet, but I heard it was like 25 million in revenue.
Okay.
Yeah, we're going pretty good.
Huh. So do you actually have look, SparkFun, you guys, us, and only a few lone survivors of all the open hardware people that went south, right? So it's a good historical case study. Like Lulzbot kind of going down a bit, They're not.
Are they?
They're not really Lulzbot anymore without Jeff, right? But right. But the graph, I like the graph. Okay, that's a historical case study. This is open hardware, and it's actually making it in a marketplace. Because for us, our case study is okay. So now we're selling homes, we can net $100K per house, and that's how I say, okay, let's put that money into R&D and get this kind of stuff that you need and other people need. So I'd like us to emerge as a model where, okay, now we're funding some serious development that helps everybody and basically goes towards the open source, zero marginal cost economy.
Got it. Yep.
There you go.
Cool.
Yeah.
Well, let me know how I can help. This answers some questions for you. Hopefully this was good.
Yeah. Thanks so much. No, that's priceless. All right.
Of course. So it's been ages and ages since we saw Katarina in New York.
Yeah. No,
how are you?
She's right here. She's right in the other room.
Oh my goodness. Excellent. Well, please tell her hi from Alicia and I.
Yeah. No, we're all working on the CDECA home open source housing work, so we're all good on that. One thing, maybe last thing on the electronics part. So open source inverters, because I mean that's a thing we'd like to open source for the house itself. Any suggestions on how to go about that project? Like, say you're developing a new open source inverter, what do you do? That's the initial question I came to you with, Nathan. I was like, hey, school me, mentor me on this process, because I need to understand more of it.
Man, you scratch an itch. So I tried to build my own whole house power wall, whatever you want to call it.
Yeah.
And I ultimately failed because of permitting and electricians, right? So nobody wants to touch that. How to do your own inverter? That's high power electronics. It's a project. I mean, it can be done. There's no magic there. I think all it takes is a dedicated open source company to get through the UL testing thresholds to make sure that people and installers are confident that it's not going to catch on fire.
The UL process, what does that add? Are we talking about like 100K, a million?
It's a great question. I don't know. I've never been through the UL testing process. I've been through FCC, which was, 10, 30,000, something to 10 to 30,000. UL, I guess it was on the same order of magnitude. So 50,000. But you're going to have to find the right people who have done high power electronics for multiple years to say, oh, this is what you need to watch out for.
Do you know any people that you could recommend? Nope. No,
I'm not a power electronic guy.
Okay. All right. Okay.
But if you've got an inverter, let me know, because I have some uses.
Yeah. Okay. No, that's awesome, Nathan. Thanks so much for your time.
And good luck. Thanks for reaching out.
Yeah. Absolutely. And Avinash, we'll stay on and continue the discussion.
Sounds good.
Okay.
If he's there.
If he's gonna wake up. Thanks a lot, Nathan.
Thank you, Marcin. We'll see you later, man.
Take care.
Bye.
Bye-bye. Avinash, you still there?